Hello students. Today we are going to start lecture 1 of chapter 1, Chemical Reactions and Equations of class 10th Chemistry.
Today we will cover the topics which are chemical reaction, chemical equation, and how to balance a chemical equation. Chemical reaction occurs every day, every time, everywhere. Like we get up in the morning, we brush our teeth. That is an example of chemical reaction, as paste is a chemical product. We bathe, soap is a chemical product. We breathe, oxygen that burns the food via respiration to produce energy is a chemical reaction. There is always a change where some chemical reaction occurs. These changes are of two types. Either there is a physical change or there is a chemical change. When there is a physical change, no new substance is formed, but the state of that product gets changes. And if there is a chemical change, a new product is formed and we don't get the reactant back. The new substance with new physical and new chemical properties are produced. What is responsible for these changes? It is a chemical reaction. Hence, a chemical reaction means the transformation of one chemical substance into another chemical substance, or the process that involves the rearrangement of structure of a substance or conversion of reactant into products. Here is an example of a chemical change in which the molecule of hydrogen is reacting with the molecule of oxygen. So we will see that the bond between hydrogen molecule is broken, as well as the bond between oxygen molecule is broken, which rearranges to get a molecule of water. Earlier, it was a bond between hydrogen-hydrogen atoms or oxygen-oxygen atoms in the reactant. But if we will see the product, the bond is rearranged and now it is a bond between hydrogen and oxygen to make a molecule of water. What is the criteria which shows that a chemical reaction has happened? For that, any of the following changes should be observed, like a change of state, change in color, change in temperature, evaluation of gas, and formation of precipitate. Here, an example is given to show each effect. If some chemical changes happened, how can we present it? Like if we take white flour, baking powder, eggs, sugar, and mix them well. If we put it for baking, it gets converted into a cake. So here is a chemical change. How do you present it? Hence, the symbolic representation of a chemical change is known as chemical equation. Here, we put the reactants on the left hand side, like we have used here flour, baking powder, eggs and sugar. And we write the product, that is cake, to the right hand side. The reactant and product, they are linked with the arrow in between. So this is the example of chemical equation. This chemical equation, either it is in the form of word or symbolic. Word equation means if we use words for the reactants as well as product. Another example is if we take sodium and chlorine, it reacts and it gives sodium chloride. Here we have taken sodium, the name of the reactant, chlorine, the name of another reactant, and they give a product, that is sodium chloride. It's a name of that product. So this is in the form of word equation. The equation in the previous slide can also be written as sodium reacts with chlorine to form sodium chloride. When instead of names of reactants and products, symbols and chemical formulas are used, then This is in the form of symbolic form. For example, instead of writing sodium, we are using its symbol as Na, and for chlorine it is Cl. The product sodium chloride can also be written as NaCl. Along with these symbols, we give subscripts also that shows their state to understand it in a better way. Like if the reactant or product is solid, we will give S, or L for liquid, G for gas. If the solution is aqueous, it will be AQ. If some gas is produced in the reaction, it is represented by up arrow. And if some precipitate is formed, it is shown by down arrow. Now we will take an example for the better understanding. Here, zinc, which is in solid state, it reacts with sulfuric acid, that is H2SO4, which is in aqueous state. It gives a product of ZnSO4, which is again in aqueous state with a hydrogen gas release. So the arrow is in up direction. Now it is very important that whatever the chemical equation is there, it should be balanced. Now for any product to be made, there will be some ingredients and there will always be a fixed proportion of quantity of all the ingredients to make a fixed quantity of product. Like again we will go back to the example of cake baking. If we'll take 2 cups of maida plus 2 tablespoons of baking powder plus 6 eggs, etc., we will be able to prepare half kg of cake. This is balancing of equation. Hence, a balanced chemical equation means the number of atoms that are involved in the reactant side is equal to the number of products side atoms. Next important thing that comes is how to balance a chemical reaction. Balancing of a chemical reaction follows conservation of mass law. We equate the number of atoms of each element in the reactant side to the number of atoms of product side. This is called balancing of chemical equation. We will study here two methods to balance a chemical equation. One is by hit and trial method and another one is shortcut technique. Now let us start with hit and trial method. Now in this method we change the coefficients, that is the numbers in front of the compound or molecule, to make the number of atoms of each element same on each side of the equation. We will understand it with an example. We have taken here iron reacting with water to give iron oxide and hydrogen. If we will see the number of atoms of iron on the left hand side, it is 1, but on the right hand side it is 3. That means it is unbalanced. Likewise, make a table to show the number of atoms of each element present in the reactant and in the product in a table form. Here in the table, we can see that hydrogen is balanced. That is, in the reactant side also it is 2 and in the product side also it is 2. But it is not the case with the atoms of iron as well as oxygen. So it is up to us either to start with the iron atom balancing or oxygen atoms balancing. Here we have taken oxygen at first. So we have seen that there is only one atom of oxygen in left hand side but 4 atoms of oxygen in right hand side. So we need to multiply the left hand side, the reactant side oxygen by 4 to make it balanced with the product side. Now here, oxygen is balanced, but hydrogen has become unbalanced. Now it has become 8 on left hand side. So what we will do, we will multiply the right hand side hydrogen by 4 to make it balanced. 8 on the left hand side of hydrogen atoms as well as 8 on the right hand side. Now if we will see, our oxygen and hydrogen atoms are balanced, but number of iron atoms is still unbalanced. So what we are seeing here is, it is 1 in the left hand side but 3 in the right hand side. So what we will do, we will multiply the iron atoms on the left hand side by 3 to make it balanced. One very important point in balancing an equation is, we can make changes in the coefficients of the atoms or molecules. We cannot make changes in the subscript atoms in a molecule or element.
Again, we will update our previous table and we will check the number of atoms of each element on either side. We will find that they both are equal. Iron is 3 in left hand side as well as 3 in right hand side. Hydrogen has become 8 both sides. And similarly, oxygen is 4 in each side. After balancing the above equation, it can be written as follows. 3Fe plus 4H2O gives you Fe3O4 plus 4H2. If we will count the number of atoms of each element either side, it will always be equal. So now the equation is balanced.
Now we will balance the same equation by shortcut technique. Let us give A, B, C, D variables coefficients for each element or molecules. Here we have given A to iron, B to H2O molecule, C to Fe3O4 and D to H2. Now we will balance each element. Iron, left hand side it will be A and right hand side it will be 3C. For hydrogen, left hand side it will be 2B and right hand side it will be 2D. Now the question arises that how it is 2B for hydrogen on the left hand side. If we will see water molecule, it is H2O, that is 2 atoms of hydrogen with 1 atom of oxygen. Hence, we have to multiply B with 2 to get the total number of atoms of hydrogen in LHS. Similarly, in the right hand side, it is 2 into D, that is 2D. That's why we have written for hydrogen atom 2B is equal to 2D. Similarly, if we will see for oxygen, it is B equal to 4C. Let's set C is equal to 1. Assume that C is 1. Then A will become 3 after putting the value of C equal to 1 in the first equation. Hydrogen B equal to 4C, that is equal to 4, and B equal to D, that is equal to 4. Now the values of all the variables are A equal to 3, B equal to 4, C equal to 1 and D equal to 4. Now put these values of variables in the equation and balance the equation. It has become 3Fe plus 4H2O, that gives Fe3O4 plus 4H2. Now our equation is balanced.